given by Kevin, so maybe I could hand it off to you.
Thank you. Sorry to disappoint you, I'm not Ardie. I'm just Kevin. But anyway, we are Thinking Machines. We are a data science company based here in Manila. And we just want to talk a little bit about one of the projects we're currently working on, which is on shedding light on Philippine poverty using machine learning, geospatial data sets, and satellite imagery. So first of all, what was the motivation of this particular project? I guess our overall motivation was the overall state of poverty in the country. So most recent estimates revealed that 3.8 million families in the Philippines live on as little as $6 a day. So this translates to around 300 pesos per day, or 10,000, just under 10,000 pesos for a whole month for a family of 5. So even in areas where the cost of living is very low, this is still very little, a very small amount to go on if you want to support an entire family. Now, in addition to this, the situation of child poverty in the Philippines is very problematic. So 3 out of 10 children in the Philippines belong to poor families. So if you are, let's say, an agency or an organization that wants to target these children, target their impoverished families and help them out, the first thing you would want to know is, where can you find these people? The problem is actually locating where these families are can be quite difficult, as we will illustrate. So consider, for example, Cebu, which is known as one of the more wealthy provinces in the Philippines. So in terms of various socioeconomic indicators, Cebu ranks quite high nationally. However, this is when you consider Cebu at the provincial level. So if you're looking at Cebu at the provincial level, it kind of doesn't tell you the whole story. What you want to, because in fact, when you zoom in at finer spatial scales, for example, at the municipality level or the barangay level, you will find that there are pockets of high poverty throughout the province. So if you were one of those agencies that we just mentioned, you would ideally want to target the areas where poverty is very highly concentrated. So in this map, the areas that are shown in red are the areas with high ratios of poor households. So you would want to focus your efforts there to help out the people who need it the most. Now, this type of data is produced from on-the-ground household surveys, which means massive teams and a lot of effort is done to send out people to go to these individual houses, thousands of houses throughout the country, and collect data. The problem with that is that's very difficult. So specifically, such surveys are very costly, so they can cost millions of dollars. And in fact, the most expensive survey to date was the recent 2015 population census, which cost nearly $40 million, or over 2 billion pesos. So because of these high costs and the effort needed and the sheer scale of these surveys, the surveys are often not very timely. They are conducted only once every 3 to 5 years, which means by the time the information is obtained, usually it's not necessarily up to date. It's not the most up to date. And finally, when this information is gathered, it's usually reported to us or reported to the public at an aggregated level, at the level of the region, at the level of the province, which, while useful, is not always useful to those organizations or efforts that want to target specific areas of poverty. So having said all of that, how did we address these problems? Our overall approach was to use machine learning in conjunction with open source geospatial data sets such as OpenStreetMaps and also satellite imagery to predict poverty throughout the country. So our main objective was to produce faster, cheaper, and more high-resolution reconstructions of poverty in the Philippines to date. A lot of this work was inspired by the work of Neil Jean and colleagues from the Stanford Sustainability Lab, where they used a similar approach. They also used satellite imagery to predict poverty throughout countries in Africa. For this project, Thinking Machines was chosen as one of the AI and data science cohorts for the UNICEF Innovation Fund, which provides support for companies that want to use innovative techniques in improving the lives of children throughout the world. So to talk more about how we did it all, our methods, I will pass you on to Issa.
Uh, great. Good morning, everyone. So I'm Isabel, or Issa for short. So I'll be I'll be the one to walk you through the methodology that we used for this project. Okay. So the main idea is basically just by using satellite images alone, you can infer the level of poverty or wealth in a particular area. So if you look at the image here, it's pretty evident that the image to the left is much wealthier than the image to the right. So, and this is because, I mean, it's pretty clear, like it has larger rooftops, it's less dense, and it has a better or more structured road networks. So if humans can tell the difference between rich and poor areas just by looking at satellite images, then machines should be able to do it much more efficiently. So the most straightforward approach to modeling or to predicting poverty using satellite images is to create a model that that takes as input satellite images and directly outputs poverty measures. Unfortunately, in order to train this kind of end-to-end deep learning approach, you would need tons of labeled training data. And for the Philippines, we just don't have that kind of data. So just a bit of context, what the data set that we use is a demographic and health survey. So the basic geographic unit is in terms of clusters, where each cluster consists of around up to 50 households. So for each household, it has a corresponding wealth index. So in the data set, there's only about 1,200 clusters. So that's not enough to train an end-to-end deep learning model. So how do we, resolve this problem of data scarcity? So what Neil Jean and his team at the Stanford Sustainability and AI Lab suggested was, instead of directly predicting wealth, why don't we predict nighttime lights instead as a proxy for economic development? So it's pretty intuitive. Urban areas that are more developed, more wealthy, tend to emanate brighter lights at night. So for example, there's Metro Manila, compared to more rural areas like Bohol, which are dimmer at night and are actually less wealthy, relatively less wealthy. Okay, so if you look at the data, you can actually see a trend where wealthier areas do tend to emanate brighter lights at night. And you can also see that poorer areas also they tend to emanate very little to no nighttime lights at all. So now you have this problem of, given a daytime satellite image, can you predict the corresponding nighttime light intensity? Where this nighttime light intensity is given by the pixel brightness value. So 0 being the darkest and 122 being the brightest. Furthermore, we binned it into 3 categories, so low, medium, and high. And so it becomes this classic machine learning classification task where, given a daytime satellite image, can you predict whether it's low, medium, or high nighttime light intensity? And to model this, we used convolutional neural networks. So for those who are familiar with CNNs, you'll know that it's possible to extract feature embeddings from the latter layers. And these feature embeddings, essentially, they're just numerical encodings describing particular patterns in the daytime satellite image. So for example, if it sees larger rooftops, if it sees more structured networks, if it sees an airplane, which is indicative of an airport, and that tends to emanate bright lights at night, it'll classify it as high nighttime light intensity. On the other hand, if it sees like a bunch of forests or just plains with a couple of houses here and there, it'll most likely classify it as low nighttime light intensity. So the main takeaway from this slide is basically for each satellite image, you can extract feature embeddings that are optimized to distinguish between low, medium, and high nighttime light intensity. So I hope that's clear. Okay, so nighttime light classification isn't actually the real task. So what we're actually interested in is wealth predictions, right? So, so going back to the concept of clusters, so each cluster consists of up to 50 households. So for each cluster, you can actually get the cluster centroid, which is just the average latitudes and longitudes of these households. And then for each cluster, you can get a number of tiles surrounding that cluster given a particular radius. And for each image in that cluster, you can now feed that as input to the nighttime lights classification model and extract the corresponding feature embedding. And you just do that for each of the images in that cluster. So for each image, you have the cluster embedding. And since cluster embeddings, for each image, you have the feature embedding. And since feature embeddings are just numerical encodings, you can actually average them element-wise. So what you get is for each cluster, you now have this cluster-level average feature embedding. And yeah, so basically you do that for all clusters. So each cluster now has this feature vector. So that's so those now are your features. You feed that and use those features to predict the corresponding wealth measures. And since we only have around 1,200 clusters, a very simple ridge regression model does the trick. So going now to the results. So how accurate are our wealth measures? So what we got is an R-squared of 0.62.5. So what this basically means is the model is able to explain around 63% of the variance. Just for context, when this study was done for African countries and Haiti and Nepal, I think the range of R-squareds is around 0.51 to 0.75. So we're somewhere in the middle. So yeah, so I can say that our results are somewhat comparable. Yeah, pretty comparable to past studies. So after making cross-validated predictions for each cluster, we aggregated the results to a provincial level, and we can show here that essentially we can reconstruct provincial level poverty maps to some degree of accuracy. So this is still pretty aggregated. So what we're actually interested in is high resolution, more granular maps, right? So we chose one particular province. So in this case, Pampanga. So just some statistics on Pampanga. It's the 8th richest province in the Philippines. And it's estimated that 3 to 5% of families are poor. But knowing these statistics alone doesn't really tell you where these families might be. So when we created, so what we did was we tiled Pampanga into 18 square kilometer tiles and did wealth predictions for each tile. And what we got was we were able to identify areas that were less poor. Basically, we were able to show the wealth distributions within the province. And we were able to identify this particular area in the left, which is less wealthy than the rest of the province. And we identified this community as Sapang Uwak, which is actually home to an indigenous community of Atas. So the poverty levels here are, so they're poorer than 76% of the Philippines, and their wealth levels are more comparable to areas like in southern Mindanao, conflict areas. And then just a few kilometers away from Sapang Uwak, you have Angeles City, which is among the country's 10% wealthiest areas. And their wealth levels are more comparable to, say, Metro Manila, Pasay, and Taguig. So it's very interesting to see the distribution of wealth within a particular province, and as well as the polarity of the wealth levels in particular areas. So you have areas that are extremely poor and areas that are very rich. Another thing that we'd like to show is we can also do high resolution mapping for conflict areas. So in this case, we chose Maguindanao. So Maguindanao is one of the poorest areas in the Philippines. Around 45% of families are poor. And if you were to do traditional surveying in Maguindanao, you'd have to go house to house and actually do the survey. The problem is that since it's a conflict area, it's very difficult to access. And from what I heard, it's, correct me if I'm wrong, but you need like military escorts in order to actually penetrate the area. So you'd actually have to risk your life to get socioeconomic data. But by using satellite images, we were able to reconstruct poverty levels, and wealth levels in this area very quickly, very cheaply. As expected, it's the overall area is very poor. There's one particular area that's sort of rich, which is Cotabato City. So yeah. So now I'd just like to draw some attention to the limitations of this method. For one, it's difficult to distinguish between different levels of poverty for areas with little to no electrification. So if two areas are very poor, one is poorer than the other, since they are both pretty dark at night, the model won't be able to pick up on this subtle difference in poverty levels. Another thing is it's difficult to predict other aspects of human development. So we did try predicting access to water, access to education, and child mortality. We found that we couldn't predict it as well as wealth. We couldn't predict it as well as we could predict wealth, probably because of the lack of a clear relationship between these variables and nighttime lights. And finally, we'd like to emphasize that poverty estimates are not meant to replace on-the-ground survey, but more like to augment them. We're just basically trying to address the limitations of these traditional surveying techniques. So now I'd like to hand the mic to Ardie to talk more about the tech stack.
Hi. So far, we've been talking mostly about the machine learning part of the research, but most of the underlying data is actually geographic data. So for dealing with geographic data, you have to have a different approach. So our data sets, for example, nighttime lights, satellite images, administrative boundaries, 18 square kilometer tiles, all of these are geographic data. And the problem is these are normally not in Excel files or CSV files. So you have to have a different approach in working with them. So normally the people who do these sorts of research, they use what's called a geographic information system, or a GIS. So the research that we did was mostly done using QGIS for the initial visualizations and data access. Afterwards, we migrated it to GeoPandas, where we could perform further cleaning, further exploratory data analysis. And it's been a very trial and error journey, sort of, since we were trying to find a mix between using QGIS for its easy-to-use nature, very drag and drop, click, but also balance it with making things more reproducible, making things faster and more efficient. And this is mainly served by using GeoPandas. So this part will mostly talk about how we think GeoPandas is useful for this sort of research, since these two tools are used for different fields of geographic research. And we think that for ML-related stuff, using GeoPandas is better, since, first off, GeoPandas is much more easily reproducible. So here we see a GIF of working with QGIS. So normally we do like drag and drop, click it, and then move it to the window. But the problem with this, well, I guess it's much more efficient, especially if you're just starting out and you want to figure out how to work with this sort of data in the first place. But the problem with this is eventually gets more repetitive, and it's actually very computationally intensive. So for example, if you see here, we loaded a barangay's shapefile, and right now it's still rendering all of the shapefiles. So one approach that we used was to just instead use GeoPandas. So you can do all of that with GeoPandas. So previously we tried opening it and then filtering out a certain province in the Philippines called Tawi-Tawi. So doing all of that takes around 30 seconds, but with GeoPandas, you can just do it with 3 lines, and you can already see how it looks like, where it is. And I think another reason that it's much more useful is that this is much more easy to follow than, for example, teaching someone where to click, what tool to use. Just representing it via code is already much more self-documenting, and it also decreases the onboarding time for other people who are going to come into the project, so that other people can start working on it, deliver value much more faster. Um, yeah, so the development time-wise is pretty good since doing it all in code is much better. But performance-wise, we're also seeing that GeoPandas is slower. But if you use, there is a workaround where if you use Python, you can actually increase the speed so that it will perform at a comparable speed to QGIS. So this benchmark is for a spatial join, which is a very computationally intensive GIS operation. So these are normally the operations that you use to compare two separate packages, two separate GIS softwares. So by using GeoPandas and Python together, you can actually get comparable speeds. So that's already a good thing. And another thing that's pretty interesting to talk about when we talk about GeoPandas and QGIS is that for QGIS, it has actually limited support for machine learning models. So it's good for more traditional GIS and remote sensing applications, but for machine learning models, you would have to install third-party plugins, and most of the time, these plugins are just focused on unsupervised classification, supervised classification, not really much on deep learning. But if you actually do all of it in Python, you can actually access the entire data science ecosystem of Python so that you would be able to do all of it all in one single environment. And that's the good thing, because if you do all of it in a single environment, you can actually make it so that you're only able to, so that you would only have to install or import the packages that you really need. So if you actually deploy these into production, it'll be much more efficient as well. And you can just add other packages if you want so that you could perform other things like, for example, pandas for data analysis and statistics. You could also import PySal, which is the Python spatial analysis library for geostatistics. So all of that cool stuff, plus more. And I think the main takeaway here is that GeoPandas is good for the ML side of geospatial. And I guess I will hand it off to Issa just to conclude with some words.
All right, so hi guys, I'm back. Just some final thoughts. So we actually presented this project to in Qatar just last week. We just basically came back from Qatar at an AI for social good workshop. So basically, it was attended by UNDP, UNICEF, who was just sharing our work. It was also research students, local research students in Qatar. So one of the researchers kind of approached me afterwards and asked me, okay, great, we can map poverty, so what? So I was just, I thought it would be pretty obvious, but I guess it wasn't. So the use case, so I just want to elucidate, at least for this presentation, the use case for poverty mapping. So last year we actually talked with UNICEF Philippines, and one of their pain points is that they have all these programs, they have all these plans for alleviating poverty, but they don't know which areas to target first. So what they actually do is they have like these documents, these pages and pages of spreadsheets. They look at incomprehensible tables and figures to figure all of this out. And like, what if we just gave them like a map, right? From one look, which areas to target. So if we do this for the whole Philippines, it would be really great, I think. So overall, I think our main goal here is to basically help humanitarian organizations, NGOs, LGUs make more informed, more data-driven decisions for their to target vulnerable communities for their humanitarian aids and programs. Also, I was talking with one social activist a while ago, and he was talking about the allocation of funds in the Philippines. I think it would be cool to map out how exactly the funds are being allocated for different regions, and kind of like hold our decision makers and policy makers more accountable for the decisions that they make by showing like a map of poverty versus the map of allocation funds. So again, just to circle back, what we want to do is to try to address the limitations of traditional surveying techniques by providing ways for faster, cheaper, and more granular estimation of poverty. Just some last words. Overall, we think preliminary results indicate that poverty estimation using machine learning and satellite imagery is a promising area of research and with a large potential societal impact. We're continuously working to improve model performance, trying to get the R-squared up. Also, we're working on making the models more interpretable. So if you remember the talk by Susie Lee yesterday, it's not enough that we create predictions, but we also need to make it, you need to explain the why behind these predictions. So I'm actually excited to use the methods that she described yesterday. So I'd just like to end with this pretty cheesy quote, but wars of nations are fought to change maps, but wars of poverty are fought to map change. Eventually, we hope to be able to map change and see positive results. Yeah, just some special thanks to our partners, UNICEF, QCRI, and some contacts from Stanford Sustainability and AI Lab. I just have two asks for the audience. So if you think that you or any organization that you know will benefit from poverty mapping or from our methodology, please, it would be really great if you could contact us, collaborate with us. Also, if you are like a researcher, if you work with satellite images, or if you just have any ideas for doing social good with AI, we're always open to talking about new ideas. We love talking about this stuff, so it would be great if you guys would just approach us. I mean, I'm an introvert, but I love talking about this stuff. So thank you so much for taking interest in our work.
All right, thank you so much, Ms. Issa. And can we invite the three speakers to be here in front for the Q&A portion? So our floor now is open for some questions to our speaker. So can we please be here in front for some Q&A? So the mic is there at the back. So can you please just proceed there? Thank you.
Hi, good morning. I am Jeff from Davao City. Before I just raise my question, I would like to thank you for the very wonderful presentation that you had. It's quite overwhelming to see that machine learning concepts are actually applied for social good. So thank you for that. Personally, I'm just curious because you've mentioned a lot of tools that are built on Python that you've used in your project. I'm just personally curious at with what challenges or problems that you have encountered using these tools in the process. Thank you.
Okay, so personally, this is actually my first deep learning project. So I had to like really learn PyTorch, and so Stack Overflow helped, you know. Also following the research methodology, it included having to change like the network architecture. So I guess that was one challenge because I got stuck with having to replace, because one of the in the methodology, you had to replace the fully connected layers with convolutional layers, so that because basically the network that we used, the pre-trained network only accepts like 224 by 224 images. So since our satellite images are 400 by 400, we had to kind of alter the network architecture. So so that was a challenge, but yeah, again, Stack Overflow really helped. It's a great community. People, you just ask questions and they answer, and sometimes they'll help you with lines of code. So yeah, that's pretty much all I can think of right now.
I guess from the use of GeoPandas itself, on the more geospatial processing standpoint, understanding your the particular resolution you need to answer your research question is important. So for example, you can have shape files that are very, very detailed, wherein a particular polygon would be encoded as having very, very many edges. So of course, when you do spatial operations using that high resolution, it takes longer, it costs more. It costs a lot more than doing the same operation if this particular shape was simplified. So I guess knowing to what level, what degree of resolution you need for your problem can help a lot in the costing and the scalability of addressing it.
Well, for me, it's more of trying to migrate to Python first mindset. So I'm coming at this from more of a GIS mindset since that's my background. But I think seeing it, the bigger picture, seeing that this is for ML and seeing that this is actually going to be used for ML models, this was mostly an out of necessity thing for me since I actually feel like I would rather use QGIS more. So basically, I was saying to Issa and Kevin that I feel like me presenting why you should use GeoPandas versus QGIS is like a Lakers fan saying they love the Boston Celtics. But I think it's pretty useful since someone who isn't familiar as much with the GIS part, you can learn it faster when you're doing it you can get into it faster when you're doing it in Python.
Hey, hi. I have one question. I'm Arvind, and I'm a wannabe social entrepreneur, and like I really like this initiative, whatever you have taken. But the question is like, do you look forward to open it up or like put it on GitHub so that people could take up and like scale it, or abstract this entire process to a normal place so that every country can take it up and like use it, right?
Yeah, so in Thinking Machines, we are big advocates of open science, open data, and open source. So one of our commitments to UNICEF is to open source this data, this work actually, and basically we're in the process of creating this pipeline where we just basically input the latitudes and longitudes of whichever areas you want to do wealth predictions for, and we should be able to predict it automatically. So if you follow our blog posts, we'll be posting there, and yeah, we'll also be open sourcing our code soon. Right now, this is still a prototype, but eventually we hope to build like some sort of API or some tool to make this more more scalable for other places as well. So.
That's amazing. Thank you.
Hello. So, first of all, thank you for this talk. And I think we all agree that we should have more of things like this where it's like a different type of CSR where companies and people of skill are helping out in terms of the social issues, right? So I have two questions, right? So first is in the 3,000 budget used to help build the prototype, what is I guess, the distribution of where the costs was allocated? So that's my first question. Then my second is that have you guys tried exploring a time element in terms of the mapping? So the way I understand it, Google has historical view of the satellite images, right? So I think it's a good way of looking at maybe in a 10-year scale, how did the wealth distribution happen across the Philippines? Yeah.
Okay, so for the first question, most of the cost comes from downloading satellite images, so it's not that cheap. It's around $1, 0.002 per request. So if you have a bunch of, if you have like millions of satellite images to download, that amounts to a lot. But for the model, once it's trained, it's pretty quick to predict, so there's not much cost there, I think. Wait, sorry, what was the time element? Okay, so right now we're doing some sort of like nowcasting. So So our data is in based on 2017 to 2018. So basically, we're just like essentially we're just augmenting what's there, but we haven't looked at the time element. That is something that we're looking forward to do maybe in the future. For this, we might be using Landsat images. So right now, what the images that we're using is Google Static Maps. So that's only available for the current year when you request it, but it doesn't allow you to request uh, images from the past. So Landsat images, although they're lower resolution, it's available for past years. So maybe we'll be using that. So it's a research that we're looking to explore further. But thank you for that.
Oh, sorry. Just to add to the second question also, it's definitely a nice idea to look at the temporal elements, the sort of temporal change in the way poverty changed throughout the Philippines. But I guess one of the limitations is that the trained, the ground truth information is very limited. So like the ground truth information is only available when the Philippines conducts these nationwide surveys. So we only have it every few years. We only have it for 2015, probably 2010, many years apart. So if you wanted to train a sort of time series model on how poverty changed, it would be a little bit challenging. So yeah, that's one thing.
So I think another good thing about these publicly available satellite images is that they have all of these different bands that you can actually use. So normally images, they're just RGB, but satellite images, they have actually around 12 bands. So you can use ultraviolet, infrared, you can use coastal. So all of these different bands, you can actually use them for different purposes, like, for example, checking out which one has built up, checking out which one has polluted waters, that sort of stuff.
Oh, commend you for the very amazing work. My question is, have you done validation of your model? And if you did, can you tell us of the certain accuracy of your system? And if not, how do you intend to do the validation?
Okay, so the validation method that we used was a nested cross-validation. So as in um, as in typical machine learning projects, what you do is you set aside some parts of the data set for training and some parts for testing. And then you do that, and then since it's a cross-validation, so you do that at, for different subsets of the data. And basically you just average the results over those different subsets. So, so yeah, we did a five-fold cross-validation. And our result is an R squared of 0.63. Yeah, so R squared is essentially, it's a measure of the goodness of fit. So if it's 1, you would expect all the points to fit, well, yeah, all the points to fit perfectly on this diagonal line. But the more error that you have, the more that it deviates. So right now, we can explain it, we can explain the, let me see. So right now, the model is able to explain around 63% of the variance, but we're working to improve model accuracy, model performance a little more by using other types of data sources, trying out other methodologies.
Yeah. So basically, we're assuming, so the ground truth surveys provide us with the true measure of wealth in these particular areas. So what we're doing to check against that is, so we assume that what the ground truth surveys produce is the truth, and our model is trained on these various features and predicts what it thinks the wealth should be in that particular area. So basically what we're doing is comparing what our model predicts the wealth to be against what the actual wealth is. And that's what it was.
Now, based on what you did, can you give us a number of a certain, and you are confident of how many percent accurate your model is? Sort of like an estimate that you are confident with.
So performance for regression tasks, our main model performance measure is in R squared, since that's what's been used in previous studies. I understand the R squared is not very interpretable in terms of, so this was actually also a question in Qatar. They asked, okay, how do you make, so what's a good R squared value essentially? Like, is 0.5 enough? Is 0.62? Their answer was, we don't, like, it's a very early, this research is very young, so it's still in development, so it's still not well understood yet. An R squared of 0. So right now we're getting an R squared of 0.63. When we asked Neil Jean from the Stanford Sustainability and AI Lab, he says that for stakeholders at least, what makes more sense is rather than looking at the R squared, is to look at the visualizations and see if it makes sense. For example, the actual predictions there are survey-based, are actual results from the survey, and then we have the predicted results. And you can see that we can, to some degree of accuracy, reconstruct it. So at least, just by looking at the data, you can see that we can, to some degree of accuracy, reconstruct poverty. But yeah, we're still working, I mean, as a community of researchers, we're still working on how to make this more interpretable, how to make it usable for stakeholders and decision makers.
Just one more follow-up question. Have you presented this to our policymakers or the government? And if you did, what is your experience with that?
Right now, we've only talked with UNICEF, Philippines. We're also working with NAPC, the National Anti-Poverty Commission. I think next week we'll be talking with DILG. So we're still in the process of presenting this. So we'll try to update you on that. But yeah.
Give us phone numbers and emails.
Hi, I'm Alvin. My question is, so you use the deep learning framework PyTorch. Is there any pros and cons compared to the popular one like TensorFlow?
I use PyTorch out of just personal preference. I find it to be more Pythonic. It's easier it's easier to integrate with NumPy. Whereas I feel like with Keras, TensorFlow, it feels like you have to learn an entirely new language within Python. Whereas with PyTorch, it's much more intuitive. So that's just my personal preference. Others, I think, have I think they like Keras. I don't know. I guess it's just yeah, depends. It's a case-to-case basis based on how a person codes. So personally, I like PyTorch. So.
Hi, I'm Mark. I'd like to commend your work. It's very nice and it's very great for the Philippines. Yeah, and then my question is, since you are talking about that it's so hard to gather data from the manual labor of surveying, is it possible that you add inputs like, say, tailored online survey form for the clients, for example, and then you add it as an input for your surveys? Since you are actually waiting for, let's say, 3 to 5 years for the actual ground data, so is it possible nga na to add an online tailored service for survey so that you can add it as well as wherever they are, they can input that survey or result and then it will display result? Is it possible for that?
Hypothetically, I think you should. It's possible, but that you have to assume that everyone has access to internet and has access to devices. For poorer areas that might not have access to this, we might end up missing out on them. So I think right now what really works is doing house-to-house surveys where you actually have personnel who actually go to each house and ask about particular ask the survey questions.
Hi, question. Actually, not a question, a suggestion. So, my name is Albert. I'm part of the organizing team. I feel really good about your project, what you're doing to the Filipino people. So just a suggestion to add other metrics to your network because I work a lot with the poor sectors in Mindanao. I've been a volunteer teacher to the indigenous communities in Mindanao. So it's a good thing that you learn also to add human factor to your metrics. Another thing is to use for the wealth network that you're doing, you can also use other aspects such as data from Petron, Shell, the oil companies, because the time series from the oil companies can see a lot to the specific wealth of certain communities. That's it. And I encourage as well all of the people here to do the same. Let's make that our model.
Thank you for that.
Yeah, my name is Ruben Canas, BNC. I worked with a couple of government agencies before. May connection yung ginagawa nila sa conflict. Yung as in conflict areas, because poverty-stricken areas usually fall into conflict areas also. And they are also connected to natural resources. So later on, kontakin ko na kayo about this. Kasi diba, they discovered that conflict areas, for example, will center around a lake, pinag-aawayan yung water resource, o kaya mountains, yung mga trees. So may relation. So you need to explore that possibility. So, I got a couple of podcasts. So you already have NAPSI. NAPSI also connected to the office of the presidential advisor of this process. Yeah, so I'm trying to connect with those people.
That would be great. Thank you so much. Nothing would delight us more than to see our work being used to make real world impact.
That's important na yung open source niya kasi kung sino man magko-control ng information na ito, lalo na elections, it's an advantage to it. So, right? Yeah.
Thank you so much.
So, yeah, so I have to say.
So, if you have any more questions, feel free to approach us later. And if you have any general inquiries, you can just email us at hello@thinkingmachines. So that's it, and I hope that we've enlightened you with our work, and thank you so much for listening.
Alright, thank you so much. I hope everyone is motivated and inspired with your